are counting how many islands there are in a grid. So ones represent an island, and then the zeros represent water. So let's look at this example here. So we will initialize islands to 0, and then loop through every cell of the grid. We start at cell 0, 0, and when we come across a 1, we want to increment islands and turn all the ones that are adjacent to this cell to 0. So we will be using a depth first search to be turning all these 1s into 0s. So we hit this 1, increment islands to 1, and then turn this cell to 0. Then we use a depth first search. We look at all the adjacent cells. We turn this into 0, this into 0, and we keep doing the depth first search until we hit 0. So when we hit a 0, we want to return the depth first search. So we turn this cell into 0. We look here, we return. Then we go down this way. This is a 1, so turn it into 0. We look at the adjacent cells. This 0 will return. This 0 will return. And this 0 will return. And then this 1 has been turned into a 0, so it would have kept going. It would have the recursion would have run again and hit this 0 and then return. So now that we've processed cell 0, 0, we'll continue on to the next cell. This is a 0, so we don't do anything there. This is a 0, 0, 0. Then we loop into the second row. This is a 0, 0, 0, 0, 0. Loop into the third row. This is a 0, so don't do anything. This is a 0, so don't do anything. Then we hit this 1, and we want to increment islands to 2. So now we have 2 islands, and we want to discard this cell or turn it into a 0. And then we do a depth first search to the right. This is a 0, so we return. Go up. This is a 0, so we return. Go to the left. This is a 0, so we return. And then we go down. This is a 0, so we return. And we've accounted for this island. That's an island right there. Then we go continue on. We hit a 0, 0. Go into the fourth row. This is a 0, 0, 0. Now we've hit another 1, so we want to increment islands to 3. And we will turn this into a 0 and do a depth first search. Go to the right. We hit this 1, turn it into a 0, and then we'll go up. This is a 0, this is a 0, and then this depth first search would have run again, looking up. That's a 0, and it would go left too, and this is a 0. And so that's how this is how I am going to approach this problem. And here is the code. So I initialize islands to 0, and then I loop through every row, which will be represented as the index of the row index in grid will be 0 I, and then we'll loop through each column, which will be represented by a j. The index of the column within the row will be represented by j. And if we reach a 1, then we increment islands plus equals 1. And then we run a depth first search. We want to give it the grid. We want to know the row index and the column index of this 1. And then we go into our depth first search, and we want to account for going out of bounds, right? So if the row or column goes outside of the grid, so if it goes outside, right, of the grid, then we just want to return. Or if we reach a 0, then we also want to return. Otherwise, we will turn the 1 into a 0 and then run the depth first search up, down, left, and right. And once the depth first search turns all the 1s of a particular island to 0, it'll continue on in the grid and return islands. The time complexity of this would be O of m n, m being the rows and n being the columns. So the idea behind that is we are looking at every single cell in this grid, and then the depth first search will have only looked at the most, it'll only have looked at each cell one time. So hypothetically, if every single cell were a 1, the depth first search would have looked at each cell one time. So that's how I get O, big O of m